Hi guys, so in this video we will be solving this problem, minimize Hamming distance after swap operations. Okay, so let's understand the problem. So in the problem we will be given three arrays: source array, target array and a swap array, and we have to calculate a value called Hamming distance. So one by one let's understand each term. What is the Hamming distance? Suppose if this is, let's suppose the initial case only, if 1 2 3 4 are the elements of source array and 2 1 4 5 are the elements of the target array. So what is the Hamming distance? What we do is that we calculate, means we compare the value at each index in source array and the target array. If the value differs, that both the value differs, then we add +1 to our Hamming distance. Otherwise we simply add 0 to our Hamming distance. So what we are seeing, both the, let's suppose there are few more elements, 6 6 and 7 7 is also present. Okay, so initially what we are seeing, 1 and 2 are different, so we'll add +1 to our Hamming distance. 2 and 1 are different, +1. 3 and 4 are different, +1. 4 and 5 are different, +1. 6 and 6 are same, so nothing will be added. For 7 7 also they are same, so 0 will be added or nothing will be added. So Hamming distance is 4. So this is what we have to do for Hamming distance. We compare each values at source and target, and if they are same then nothing will be added. Otherwise +1 will be added to Hamming distance, and we have to calculate the minimum Hamming distance. What we can okay, we have to calculate minimum Hamming distance. And how will we minimize Hamming distance? That is by using this swap array. And what is this array? Swap array is, it indicates, means it denotes some indexes. Okay, so 0 and 1, it denotes 0 and 1. It means that in the source array I can swap 0 index at 0, element at 0 index, and element at 1 index. I can swap these two elements. Similarly there is 2 and 3 present, so I can swap the elements at index 2 and 3. Okay, but it is not like that we can use it only once, or we can use it in this pattern only. It is that we can use this as many times as I want. Like if I want 0 and 1, I can use it as many times as I want. Let's suppose there is one more, 2 3, 0 3 is also there. So what I can do, I can use like something like this: 0 1, then 0 3, then 2 3, then again 0 3, again 0 1. I can use this as many times as I want. Order does not matter, and number of times I am using them also does not matter. So I can use them any number of times in any order. What I have to do is that I have to use this swap array and rearrange the elements in the source array such that the Hamming distance minimizes. Okay, so that is what our task is. So I guess the problem statement would have been clear. Now let's analyze it for this example test case. Let's suppose 1 2 3 4 is given to us. So what we can do is that, what we are seeing in the target array, we want 2 1, something like this. And what we are seeing, we have a swap of 0 and 1. So if we swap 0th and 1 index, what we will get? We will get 2 1, 3 and 4 full. Now what we are seeing, that we want 3 and 4 is present in source, and we want 4 over here. So if we use this swap 2 and 3, we will be able to get this 4 at index 3. So if I use this swap 2 and 3, then we will get something like this: 2 1 4 and 3. Okay, we can use more, means if we want we can try more swaps, but we are not going to get anything better than this configuration. Okay, so eventually what we will get is 2 1 4 3 and 2 1 4 and 5. Okay, now if we calculate the Hamming distance, what we will get? 2 and 2 are same, nothing will be added. 1 and 1 same, nothing will be added. 4 and 4 are same, nothing will be added. 3 and 5 are not same, so +1 will be added. Okay, so Hamming distance for this particular config, means source, target and swap, will be what? 1. So this is what the solution will be for this particular problem. So I guess now the problem would have been clear. Now let's move on to the approach, like how are we going to actually solve this problem. Okay, how can we solve this? So for that, I have like a bigger test case. So that I could explain more better. Let's suppose, if we one by one, let's look at the things one by one. Okay, so we have a bigger swap array this time. Like, but swap array, there is something we can get from this swap array. What? Let's suppose we have an array. If we have a small array, let's suppose I'm taking another array for example. For now, zero, no, let the elements of this array be a1 2 3 4 and 5. Let these be the elements, and swap array here let be what? 0 and 1 be one swap array, 1 and 2 be, and 2 and 3 be a swap array. Okay, so if we look at these swap arrays individually, what we can see is that, what we see that we can swap 0 and 1 element. So what I can think is that at most what I can get from this is, what I can get is something like this: 2 1 3 4 5. This is the at most I can get from this swap, nothing else. If I reswap this, then again I will get the same configuration. If I look at this swap 1 and 2, then at most what I can get from this swap, I can get something like this: 1 3 2 4 5. If I reswap it again, I will get this particular configuration. And if I look at this swap 2 and 3, then I will get something like this: 1 2 4 3 and 5. If I reswap it again, I will get back to the original result. Okay, so if we look at these swaps individually, then we are not going to get enough like configurations. But what I have told you earlier, like what I have told you, that we can use this swap any number of times. Like 0 1 can be used any number of times, and order also does not matter. Like I can use 0 1, then 1 2, then again 0 1 I can use. If I use this particular configuration, then I will be able to generate more patterns, like more particular combinations of these numbers I will be able to generate. Okay, so let's look at it something like this. Let's suppose eventually I was at max, what I was able to do: 0 1 1 2 and 2 3, 1 2 and 2 3. What I was able to do, I was able to swap only adjacent elements. Like for 2 1 I was able to swap, or I was able to swap 2 3, or I was able to swap 3 4 adjacent. Nothing else I was able to do. Okay, but what I am saying is that if I use first, if I use 0 and 1 swap, if I use 0 and 1 swap first, what I got something like this: 2 1 3 4 5. Now I am using 1 and 2 swap. So what I will get if I use 1 and 2 swap, I will get 2 3 1 4 5, 2 3 1 4 5. Now if I look at the result, what I have done, I have done a 0 and 2 swap. So what are we seeing from here, that there is one element common in 0 1 and 2, and we are able to group these elements. Since one element is common between 0 and 2, I can make some combination of 0 1 and 1 2 swap, and I will be able to perform a 0 and 2 0 and 2 swap. Okay, so this is what I wanted to focus upon. Like you can group this swap. If there is some common element between two swap, then we can group this swap, and there exists a combination by performing which we will be able to perform swap any element from any index to any other index in that particular group. Like we saw over here, 0 and 1 is one group, 1 and 2 is another group. One element is common between 0 and 1, so we can group this element into a single group: 0 1 and 2. And just now I saw that first I performed a 0 1 swap followed by a 1 2 swap, and I am able to get a 0 2 swap. Okay, so we can group these swap indices if they have something in common. Let's take one more example. If suppose we have a swap something like this, we have a 0 1 swap, 1 2 swap, and 2 3 swap. So I can, since there is something common between 0 1, 0 and 1, and 1 and 2, one element is common, so I can group it: 0 1 and 2. Okay, now if I look 0 1 2 and 2, there is something common between 0 1 2 and 2 3, so I can group it: 0 1 2 and 3. Now since these are in a claim in a single group, so what I'm saying is that I can swap any indices between this group. Like I can make a 0 3 swap, I can make a 0 2 swap, although it was not even present originally. Like there is no 0 2 0 3 swap originally present, but there is, we can make some combination of 0 1 1 2, and we will be able to generate a 0 3 swap. Let's take an example. Let's suppose there is an array of 1 2 3 4 5. There is no such combination of or let's suppose there is no combination of uh, 1 and 3 swap over here. Okay, like 0 1 1 2 and 2 3 is present, but since they are in a same group, so I'm saying that we will be able to perform a 1 3 swap by some combination of these swaps. Okay, let's see if we are able to perform it or not. Okay, so 0 1 2 3 and 4, these are the indices. So I want to perform a 1 3 swap, 1 3 swap. Or how will I do that? Means I want 2 to go over here. What I can do is, first I will perform a if I perform a 1 3 swap, what should be my result? My result should be something like this: 1 4 3 2 5. This should be my result. Okay, let's see if I'm able to achieve it using some combination of these swaps or not. What I will do, I will first perform a 1 2 swap. Then what I will get, I will get something like this: 1 3 2 4 5. Then I will perform a 2 3 swap. 2 3 swap. If I perform a 2 3 swap, then what I will get: 1 3 4 2 5. Okay, now if I perform a 1 0 1 and 2 swap again let's perform a 1 2 swap, then what I will get: 1 4 3 2 5, and I am getting the final result, right? So by some combinations of these swap I am able to get it. So we can group this, means if there is some common elements, we can group these swaps into a single group, and we will be able to swap elements in a single group by some combinations. We will be able to swap any two indexes. Okay, so this point is useful to us. So we will be grouping these indices like swap array, we will be grouping it. Okay, so now let's see how will we be grouping it. We will be using disjoint set union data structure for this. Okay, we will be using disjoint set union data structure for grouping it. What we will do is that, let's make an array. So for this problem, what we will be doing, let's make an array. So at most we have what, 0 1 2 3 4 elements. At most we are going to have 4 elements, means 4 indices. So 1 2 3 4 and 5. Okay, initially 0 1 2 3 and 4. Initially what we do, will it is a parent array. So what we will do in disjoint set union, every element will be parent eventually. Okay, now one by one what we will see, which elements can we group. Okay, so we are seeing that 0 and 4 are in a single, 0 and 4 can group, like 0 and 4 are swappable, so we will group 0 and 4. Okay, so 0 and 4, let make 0 as parent, so 0 will be parent. For 4 also 0 will be parent. Now 4 and 2 are in a group, it is given, but 0 is already the parent of 4, so what will happen, 2 will also start pointing to 0, and parent of 2 will be also be what, 0. Okay, now let's move on to the next element. 1 and 3 are in a group. Okay, okay. 3 points to 1, no problem. Now 1 and 4 are in a group, but 4 already points to 0. 0 is leader of 0 is leader of 4, so 1 will also what, point to 0. But here what we are saying, 3 is pointing to 1, 1 is pointing to 0, so 3 will also start pointing to what, 0. So for 3 and 1 also parent will be what, 3 also parent will be 0. For 1 also parent will be 0. So in this case all elements started pointing to one particular element only. That means what, 0 1 2 3 4, we can swap the elements at these indices. Means I can swap element at 0 to 1 2 3 and 4 any of the position. Same for 1, I can swap the element at index 1 to 0 2 3 4 any of the positions. Okay, so this is what is, let's move on to the problem part. So now this much part is clear. Now how are we going to solve this problem? What we are saying is that these 4 elements, means these group of 5 elements can be swapped among itself. So these represent indices. Okay, so let's make actual values also. What are those values which can be swapped? So since 0, index at 0, index at 1, 4 and 2 3 can be swapped. Okay, so what are the elements at index 0 1 2 3 and 4? So index 5, index 1, index 2, index 4 and index 3, these 5 are the elements. So these 5 indexes in elements are there which can be swapped among these indices. Okay, so if I want a 5 to come at index 1, I will be able to perform that. If I want a value, if I want 3 to come at index 0, I will be able to perform it. That is what it meant. Okay, so this part is clear. So how will we move on? So what will we do? We have done this much part. After that we'll move on to the target array. This is our target array. Target array 1 5 2 4 and 3. This is index 0, index 1, index 2, index 3, index 4. Our source array is what, 5 1 2 4 and 3. This is our source array. Index 0, index 1, index 2, index 3, index 4. Okay, so in my target array, when I see target array says that I want index at index 0, I want 1. Target array says, so can we have an index, means can we have value 1 at index 0? So what we are saying, index 0 and index 1, all these are connected, like what, these are connected. So can we have an index 1? In this particular case all the indexes are connected, so no problem at all. So means we can simply swap any values from any place to any place. So we want a 1. Do we have a 1? We are seeing that yes, we have a 1. So there is a 1 present at some other location, but it will get, means we can swap it by some combination of some swaps, but we will be able to bring it to place 1, and we have one particular value of such 1. So it is possible. So we said yes, we use that 1 and we will be able to provide 1 to you. So I said okay. So that means that in my target array I am able to swap, by some possible combination of swaps, I am able to bring the 1 at position 1. Okay, now let's move on to the next element. And from next element, target array says that I want a 5 at index 1. So again, since all the indexes are connected, so I will be able, if I have a 5, then I will be able to bring it at this location by some possible combination of swaps, but only I have to check that whether I have a 5 or not. So I'm saying yes, I have a value of 5. That means I says okay, I will be able to bring it, man. So says okay, yes, I will be able to bring the 5. Then says okay, we move on. We are able to move on. We are able to bring a 5. Now this target array says I want a 2. So since all indexes are connected, I will be able to bring a 2. Only point is that whether I have a value of 2 or not. So I check in my unordered map or in my container that do I have a 2. Yes, I have a 2. So I said that let's use that to bring to this particular position. So I brought 2 to this particular position. Okay, now let's move on to 4. Again, I will be able to bring 4. Only the point is that do I have a 4 or not. I have a 4, so I use that 4. Okay, I brought it to this particular position. Same for 3. I have a 3. I used it. I brought it to this particular position. After that, after this particular operations, what I got, my source array got converted to what? 1 5 2 4 3, and my target array is what? My target array is also 1 5 2 4 3. My target array is also 1 5 2 4 3. Now if I calculate a Hamming distance, what I am getting, these are same 0 0 0 0 0. So my Hamming distance is what? 0 in this particular case, since I was able to replicate the target array by using these particular swaps. Okay, so this is the algorithm which we are going to use. I know there are some more points which are need to be explained more better. What we will do is that we will move on to the coding part for now. While coding, there are some points which are needs to be explained. So when those points come, we will come back to this particular part and we will explain. We will try to look upon them. What are those points? Okay. So for now, whatever we have understood, let's try to make these groups. Let's try to try and write some code, and then let's get back over here. Okay, so for now let's move on to the coding part. This is not required to us. Yeah, this figure will be required to us a little bit, like this array part and all this. So let's move on to the coding part for now. So now let's now try to code it. So as started, what we will do, we'll start with making groups. So for that, let's make parent array and all that stuff. Vector of integer, parent of, let's make one more thing, integer n equals to source dot size. Okay, why? Since swaps array contains what? Indexes of elements which you can swap. So this can at max go to what? The source length. So that is what we will do, vector of integer of parent of size n. Okay, let's initialize the parent. Initially all elements are parent of itself. Let's do that. Parent of I equals to I. Let's make a rank array also. Vector of integer rank of size, and let's initialize it to 1, since initially every element has a rank of 1. Okay, now what we were doing, since we were moving on to the swap array, like 0 and 4 are in a group, so we were marking parent of 0 and 0 as 4, same for 4 and 2. So one by one we are moving on to the swap array. So let's make the group by moving into the swap array. So for vector of integer swap in allowed swaps, what we will do, integer a equal to swap of 0, integer b equals to swap of 1. Now we will check whether they are a 0 and 4, whether they are a part of a same group, like so one for 1 and 3, whether they are a part of same group or different group, and based on that we will join them. Okay, like what we do in the join set, we'll do the same. So let's make integer leader of x equals to find a comma parent, integer leader of y equals to find b comma parent. If leader of x is not equals to leader of y, means they are belonging to the same group, then we need to join them. So if rank of leader of x is greater than rank of leader of y, then what we will do, parent of leader of y equals to leader of x. Else if rank of leader of y is greater than rank of leader of x, then what we will do, parent of leader of x equals to leader of y. Else we can make any one of them as parent. So parent of leader of x equals to leader of y, and plus rank of leader of y. Let's write find function also. So let's write a function find integer, find integer x and vector of integer parent. If x equals to parent of x, then we'll simply return x. Otherwise, what we will do, we will return parent of x equals to find parent of x comma parent. Okay, so we have written find function. So we are done till now. So we are able to make this parent array and we are able to make this group. Okay, now what we have to do, we have to means use this target array, means calculate the Hamming distance. So what we were doing is that at each group we were storing what these elements this particular group had. Let's suppose there are few groups. 1 2 3 was a group of indexes which we can swap. 4 5 7 was a group of indexes which we can swap. So what it represents, these elements between these group can be swapped by some combinations. Okay, so what we were storing, okay, elements are stored, but we were also storing like which elements are present over here. Like, okay, you have 2, you have 3, and you have 7 element with you, so these can be swapped among itself. Okay, now let's suppose this group also, let's suppose this group has 2 2s, 3 5 times and 5 2 times. Okay, then how will we store it? So we cannot simply store it. So what we will use, we will use some map data structure. We can use some map data structure, like we will use unordered map over here. What we will store, we will store element along with frequency. Like 2 is stored 2 times, 3 is stored, 3 has 4 times, and 5 has 2 times, like this. So we will use an unordered map for this storing this particular data structure, this particular structure. Like elements between 4 5 and swap can be 4 5 and 7 index can be swapped, that is for sure, by some combination. But what elements are there, like what are the values of those elements? So for that we are using an unordered map of integer comma integer. We will be using this for storing this particular data structure, means this particular. Okay, now what we want is that each particular group 1 2 3, like what, how we are denoting, each particular group has a leader, like 2 is the leader in this particular case. 4 5 7, let's suppose 4 is the leader, 4 5 and 7. So what we will do is that each particular group has a leader and leader has some values. So what we can do is that in this group we can swap these values anywhere by some possible combination. Similarly, in this group we can swap these value by any possible combination. So what we will do, we will make a data structure, means we will store it something like this: unordered map of integer comma unordered map of integer comma integer. This data structure will be used to store this. Why? This part is the same for storing this. Okay, now each group has a leader and leader has this particular data structure. So what we will do, for storing leader we are using it an unordered map. This will be used for storing leader, and this is what those elements the leader have. This will be used for storing the elements. Now this will help us to determine like that which elements can be, means swapped between this group of, means this particular indices. Okay, so we'll use this data structure. So what we will use, unordered map of integer comma unordered map of integer comma integer. Let's name it as map1. So what we will do, we will one by one fill like which particular group has which elements. So for that, for integer I equals to 0, I is less than n, plus I, integer leader of x equals to find I comma parent. Okay, like what we'll do, one by one we'll move to each of these elements, that we'll go to index 0 and I will ask who is your leader. 1 says 1, 0 says 1 is my leader. I will go to 1, I will ask to 1 who is your leader. 1 says 1 is my leader. I will go to index 2, I will ask who is your leader. 2 says 1 is my leader. So eventually 1 0 and 2 are in a group. So I says okay, then what I will do, whatever the value is stored at index 0, so at leader of 1, leader of 1 has this data unordered map data structure. So leader index 0 has 5, so at index 5 I will plus 1. I'm sorry, in order map I will plus 1. Index 1 is also a part of this particular group, so it has a value of 1, so in front of 1 I will add a plus 1, and so on I will do. So let's do that. So first I found the parent, who is the parent, and let's suppose value is equal to what, source of I. Okay, then what I will do, I will increment map1 of leader of x comma value. Okay, now let's make a variable Hamming distance equals to 0. Now what I will do, for integer I equals to 0, I is less than n, plus I. Okay, now this one part is done. Let's rub this part. Don't need this. What we will do is that after making this data structure, what we will do, now we are iterating on this target array. Okay, now we are checking that at index 0 I want a value 1. So what I will check, what I will do is that I will check in the 0, index 0 means whatever they have this data structure, do they have a value 1? If they have a value 1, then I can do with some possible swaps, I can bring this value 1 to this particular location. If they do not have a value 1, then I will increment the Hamming distance, since if they do not have a value 1, they will not be able to bring it. But if the leader group of 0, if they have a value 1, then I will be able to bring it over here. Okay, so we will do that. So one by one we will check who is the leader. So integer leader of x is equal to what, find I comma parent, and what is the value which is required, value is equal to target of I. Now I will check if map 1 of leader of x comma value, if it is less than or equal to 0, then means they do not have that particular value, so Hamming distance will increase and continue. Otherwise what will happen, they will be able to bring it, so no problem, I will simply decrement the value of that particular value. Okay, Hamming distance will not increase. Finally, after this, what we have to do, we have to return the Hamming distance. Okay, so this is for the coding part. So we are almost done with the code. So yeah, so this is the code for this particular problem. So currently test cases are not uploaded in our on our portal. By the time you will code this problem, test cases will be updated, so you can use the code to submit this particular problem. Okay, so I hope you guys would have understood the video.